Hello everyone, welcome back to Neet and JEE Preparations Physics Test number 4. So as usual, before attending this video, please go to the description and click the link for writing the exam. All the best. Now let's discuss about the question number 1. A time varying force F is equal to 10 root T starts acting on the 3 kilogram block kept on a rough horizontal surface. You can see in the picture there. Coefficient of friction mu is given the 0.2 at a time t is equal to 0. The time at which the block leaves the surface is. So what we have to calculate here? The time at which the block leaves the surface. So just before doing this question, let's resolve this force acting in vertically and horizontally. What is the component along horizontal direction? You can see here that is equal to F cos 45 and the vertical component is F sin 45. Okay, F cos 45 and F sin 45. Which all other forces are acting on the 3 kilogram block? You can see from here on the block there is a force which is acting downward, that is a weight mg, that is equal to 30 Newton, that means 3g, correct? That is equal to 30 Newton. As usual, there will be normal reaction force will be acting, that is equal to N. So which all forces are acting vertically upward? One is N, other one is F sin 45. And which force is acting vertically downward? That is equal to 30 Newton. So if you write the equation in vertical direction, you can write here N plus F sin 45 is equal to 30 Newton. In the question it is talking about the time at which the block leave the surface. The block leave the surface means what? That moment the normal reaction force must be equal to 0. The normal reaction force is equal to 0 when F sin 45 is equal to 30 Newton. Alright. So what is the F here? That is equal to 10 root 2 into T sin 45. Sin 45 is equal to what? 1 by root 2, which is equal to 30. Root 2 cancel and 0 0 cancel. So time is equal to 3 seconds. So option C is the correct answer. Now let's discuss the question number 2. You can see in the picture there. Okay, a block is held with a string here which is parallel to the inclined surface of the wedge, and the wedge is moving with a velocity t square divided by 2. We have to calculate here at what time block will just break the contact. Just to break the contact means the normal reaction force must be equal to 0. So let's draw the free body force diagram for the small m. This is an inclined surface. So this is the small m. So we can resolve here mg is acting vertically downward. If you resolve this mg, we can write here two values, and theta is given this is the 45 degree. So this become mg cos 45 and here it become mg sin 45. And one more force is acting, that is upward, vertically upward, that is equal to normal reaction force. Now when the wedge is moving, right, wedge is moving with a velocity, so that we can say here it is accelerating right hand side. Where what is acceleration? Acceleration is equal to dv divided by dt, where velocity is what? D by dt of t square divided by 2. If you differentiate this one, you will be getting about t. Answer is equal to what? T meter per second square. You can see here wedge is accelerating towards the right, so there will be a pseudo force will be acting on the small m towards the left hand side. We can write it as what? Ma. If you resolve this ma into two components, there will be one component which is acting along the normal reaction force, can be written as ma sin 45. Ma sin 45. Now you can see the question here, at what time block will just break the contact with the wedge? You see the vertical direction forces, you can say here n plus ma sin 45 is equal to mg cos 45. mg cos 45. So at what time block will just break the contact? When normal reaction force is equal to 0. When the normal reaction force becomes 0? It becomes 0 when MA sine 45 must be equal to mg cos 45. M cancel. Now what is A? A is equal to T, right? So T into 1 by root 2 is equal to G into 1 by root 2. So what is the value here? T is equal to G, that is equal to 10 seconds. So which is the option here? Option A is the correct answer. Now look at the question number 3. Two blocks of masses 3 kg and 2 kg are placed side by side on an incline as shown in figure. A force F is equal to 20 Newton is acting on 2 kg along the incline. The coefficient of friction between the block and the incline is same. It is given the 0.1. Okay, so mu is equal to 0.1. Find the normal contact force exerted by 2 kg block on 3 kg block. So the normal reaction force we have to calculate. So let's draw the free body force diagram for both the block. So this is, just imagine this is the incline, and this is the block of 3 kilogram. Okay, this is the 3 kilogram block and this is the 2 kilogram block. Separately I have drawn here to draw the free body force diagram. Now let's draw which all forces are acting on 3 kilogram. So first of all, mg will be acting vertically downward, correct? Same way here also there will be mg will be acting vertically downward. Mg means here 2 into g, here it becomes 3 into g. Okay, now that means once again this mg can be resolved into two components. So here also it can be resolved into two components. Angle is given there what, 37. So this is the angle given the 37. So here it become what, mg cos 37. Here also mg cos 37, and here it become mg sin 37, and here become also mg sin 37. But here masses are different. Okay, m here what, 3 kilogram, here m means what, 2 kilogram. Okay, don't be confused in that one. Next one, there will be normal reaction force will be acting on 3 kilogram, that is acting upward, so definitely will be different than the 2 kilogram. So we can write here n1, and here also there will be a normal reaction force is acting, we can write it as n2. And what are other forces are acting here? You can see here when the 3 kilogram block is sliding down, there will be friction will be acting in this direction, say it as F, where F is equal to what, mu mg. And here also there will be a friction will be acting backward, say it as F, that is also equal to what, mu mg. Masses are different. Okay, I am not writing F1 and F2, simply writing F itself. That means F is not equal here. When substituting the mass, it will be different value. Now one more force will be acting on 3 kilogram, that is the normal contact force due to 2 kilogram, correct? We can write it as N. Same way there will be same normal reaction force or normal contact force will be acting on 2 kilogram by the 3 kilogram, right? That is also here also one force will be the, that is N. So these are the forces are acting on the 3 kilogram block and 2 kilogram block. Now you apply Newton's second law. Okay, Newton's second law. What is Newton's second law? Resultant force is equal to mass into acceleration. So let's use the equation for 3 kilogram block. So if you use the 3 kilogram block, you can see here mg sine 37 plus n minus f must be equal to 3 into acceleration. That is, resultant force is equal to mass into acceleration. Now what is m? M is equal to 3, g equal to 10, sine 37 is equal to what? 3 by 5 plus n minus, what is f here? F is equal to mu into n1, where n1 is equal to what? Mg cos 37. So we can write here what? Mu f is equal to mu mg cos 37. That is equal to, mu is what? 0.1, m is what? 3, g equal to 10 into cos 37 is equal to what? 4 by 5, that is equal to 3a. Now you just do the calculation, you will be getting here what? 18 plus n minus, you see this one here 2 times 8 into 3, 24.1, that is 24 into 2, that is equal to 2.4, that is equal to 3a. See this one, equation number 1. Same way, use the same equation, Newton's second law, in the second block. In the second block, if you use this one, mg sine 37, okay, minus n minus F. Now you see on the second block there is one more force is that we forgot to write, that is the force, applied force. Applied force is equal to what? F, it is given there. So I can write it here, plus F must be equal to mass into acceleration, that is equal to 2 into A. So once again we use the mass here, mass is equal to what? 2, 2 into 10, sine 37 is equal to what? 3 by 5 minus n, then again minus F. What is F here? F is equal to, once again same formula, mu into normal reaction force. Here F is equal to mu into N2. That is F is equal to mu into mg cos 37. Here m is equal to 2 kilogram, right? So we can write here what? Mu is what? 0.1, m is 2 kilogram, and g is 10. Cos 37 is equal to 4 by 5 plus F. What is F given there? F is given there, that is equal to 20 Newton, which is equal to 2A. Which is equal to 2A. That means if you do this calculation, you will be getting 32. 32 minus normal reaction force minus what is remaining one is coming here, 5, 2 times 2 to the 4, 4 into 4, 16, 16 into 0 0.1, 1.6. 1.6 is equal to 2 into A. Say it as equation number 2. Now what you have to do here, solve this equation and get the acceleration. After solving, you will be getting the acceleration. Say it as acceleration is equal to 23 divided by 2.5. Okay. Now if you substitute this value in any one of the equation, you will be getting the normal reaction force is equal to 12 Newton. Option C is the correct answer. Now let's do the question number 4. A block of mass small m is placed on a smooth wedge of mass capital M as shown in the figure. Just after placing block m over the wedge m, what all things will happen here? 4 options are given there. You have to find one by one how many options are correct here. First option, the wedge moves horizontally along negative x-axis with respect to the ground. Is that correct or not? Small m is now sliding downward, right? When it is sliding downward, which all forces will be acting? That is mg sine theta is acting in this direction, right? Okay, so just an example, mg will be acting vertically downward. So mg sine theta will be acting in this direction. Mg cos theta will be acting in this direction. Any more forces are acting there? You can see here in the first option it is given the wedge moves horizontally along the negative x-axis. That is correct only. When this small m slides downward, wedge will move towards the left side. So option A is correct there. Now when the wedge is moving towards the left, definitely there will be a pseudo force will be acting on the small m, right? That will be acting in this direction. Say it as m into A. That is a pseudo force acting there, right? Okay, now second option you see, two forces are acting on the block according to stationary observer. That's correct only, no? When an observer is watching from outside, he can see only two forces. Which are the two forces? One is mg and other one is the normal reaction force. Mg and normal reaction force. So option B is also correct. Now let's see the option C. The horizontal acceleration of block and wedge are equal according to stationary observer. Is that equal? Acceleration mean force divided by mass, right? Here you can see forces are maybe equal, pseudo force as well as this force will be equal, but the masses are different, no? You see this is a capital M and this is small m, so the accelerations are not equal, so option C is wrong one. Now last option, the horizontal forces acting on the block is opposite to the horizontal force acting on the wedge according to the stationary observer. That is correct, no? So option D is also correct. So in this case, the last option is a correct one. Okay. Now let's do the last question. Two blocks of mass capital M, that is 5 kilogram, is given the 5 kilogram, and mass equal to 3 kilogram, that is on the 5 kilogram block, rest on smooth horizontal surface as shown in figure. Coefficient of friction is given the 0.5 between the blocks and the maximum horizontal force which can make them move without separation. That means when the force is applied on the 5 kilogram block, the 5 kilogram block and the 3 kilogram block must move together. That is given the move without separation. Now let's draw the free body diagram for 3 kilogram block. So this is the 3 kilogram block. Which all forces are acting on 3 kilogram block here? A force is applied on 5 kilogram block, that is given the capital letter F. So when the force is applied, definitely the pseudo force will be acting on 3 kilogram block. So you can mark here the pseudo force, which is equal to small m into A, acceleration. When the pseudo force is acting on the block or in between the block, there will be friction force will be acting here. What is the friction force here? That is equal to mu mg. That is equal to mu mg. So in this case, the two blocks are now moved together without separation. So we can write here what ma must be equal to mu mg. Ma is equal to mu mg. So here m cancel. So acceleration is equal to what? 0.5 into 10, that is equal to 5. Okay, 5 meter per second square. So we got now acceleration. Now, how much force is now applying? Force is equal to, if you use the Newton's second law, force is equal to mass into acceleration. So F is equal to, what is the mass here? Mass is equal to 5 plus 3, that is equal to 8 kilogram into, what is acceleration now here? 5 meter per second square. So what is the answer here? F is equal to 40 Newton. Kilogram meter s to the power minus 2, 40 Newton. Clear? So what is answer here? Option B is the correct answer. I hope you understood these 5 questions. We'll meet next Sunday, 8 p.m. Okay. Thank you.